Important ratios in trigonometry. There are three very important ratios used in trigonometry that use the opposite, the adjacent, and the hypotenuse sides of a right triangle, which we explored and figured out how to label in our previous lesson. The three ratios are number 1, opposite over hypotenuse, 2, adjacent over hypotenuse, and 3, opposite over adjacent. Remember, which measurement you calculate depends on the information given to you in the triangle and the location of the angle. So remember that the opposite and the adjacent sides will switch depending on where your given angle is. So let's go through some examples and see how these ratios work. So the example says, use the following triangle, so this DEF right here, to find the trigonometry ratios indicated below. So the first thing I want to do if I have a right angle triangle and I'm dealing with trigonometry is to label my sides with opposite, adjacent, and hypotenuse. So right across from the right angle is your hypotenuse. My angle F is the one that is given to me, and so I want to label the side across from that, which is the opposite, and the leftover one is adjacent. So part A says to write a ratio comparing the length of the side opposite. So ratio is a fraction, the opposite to angle F to the length of the hypotenuse. Then express the ratio as a decimal rounded to 3 decimal places. So my ratio is opposite over hypotenuse. So now I'm just going to plug in the numbers for those sides from my given triangle. So the opposite side has a measurement of 2 meters. My hypotenuse side has a measurement of 5 meters. And now I'm going to divide these two numbers. So remember that a fraction is the same as division. So you can do 2 divided by 5. And 2 divided by 5 gives me an answer of 0.4. Now, it says to round to 3 decimal places, but I don't have 3 decimal places, so 0.4 is fine to leave it as. The second part of this example asks us to write a ratio comparing the length of the adjacent side to angle F to the length of the hypotenuse. All right, so now let's take a look. The length of my adjacent side is 4. The length of my hypotenuse side is 5. And if I divide 4 by 5, I get 0.8. And in the last part, C, it asks me to write a ratio comparing the lengths of the side opposite to angle F to the length of the adjacent side, and then express this ratio as a decimal rounded to 3 decimal places. So my opposite side is 2, my adjacent side is 4, and 2 divided by 4 gives me 0.5. You will see why it's important to not only be able to identify what your sides are and express those as a ratio, not only as a fraction, but also as a decimal number, when we get into more of our complicated questions where we're trying to find missing sides of a triangle or missing angles of a triangle using trigonometry. Let's finish it off with 3 more examples. So for each of these triangles below, we want to determine the ratio to calculate, and we want to round your answers to 3 decimal places. So here is my angle that's given to me, and this is my first example. So this is across from that angle is my opposite side. Across from my right angle is my hypotenuse, and the leftover side is the adjacent. Now I have to think about what sides do I know? Well, I know my hypotenuse and I know my opposite. So the ratio that uses opposite and hypotenuse, if I go back up to the top of my page, is right here, so opposite over hypotenuse. So because of those are the only two measurements I know in my triangle, that's the ratio that I'm going to use. So it's going to be the opposite over the hypotenuse. And now I'm going to plug in my measurements. My opposite side is 4. My hypotenuse side is 6. And 4 divided by 6 is 0.667. So always round if you need to that third decimal place. For part B, across from my right angle is my hypotenuse. Across from my given angle, L in this case, is my opposite side. And my leftover side is the adjacent. So what measurements do I know in this triangle? Well, I know my opposite side, which is 9, and I know my adjacent side, which is 8. And if I look back at my ratios at the top of the page, the ratio that involves the opposite and adjacent has the opposite on top and the adjacent on the bottom. And now I'm going to plug in my numbers. So I have 9 over 8, and 9 divided by 8 is 1.125. And in this last example, I start by labeling the sides of my triangle. Across from the right angle is your hypotenuse. Across from your given angle, which this case is x, is your opposite side, which is the leftover side right here. So again, I want to identify what my sides are. I know my hypotenuse side. I know my opposite side. And again, this is very similar to that first example. The ratio that uses opposite and hypotenuse shows the opposite on top and the hypotenuse on the bottom. And so I plug in my values for the lengths of those sides. So 3.2 over 11.5. And I'm going to go ahead and divide those. And that gives me a value of 0.278 when I keep 3 decimal places. If you have any questions about this lesson, please reach out, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.